Hello, I'm Skylar Hart with Team 2. This semester, our team has been working on the collection and characteristics of RF signals using software-defined radio. The goal of this project is to use software-defined radio to take the in-phase and quadrature data from a signal and identify certain characteristics. Several reasons why someone would want to use this would be to deconflict RF spectrum, to design cognitive radio networks, or other military applications. Team 2 is comprised of Guillermo, Hunter, Marco, and myself. We broke this project down into 4 different phases: planning, research, development, and implementation. With the assistance of our mentor, Todd Simon from General Dynamics, we have completed the first 2 phases of our project. Hunter will introduce the first phase, planning.
I'm going to talk to you a little bit about our phase 1. During this phase, we established the scope of our project, which was to write an algorithm that could identify and characterize signals within a given frequency range. During this time, we also established a timeline for completing the project that gave us room to implement and test the design, as well as prepare our final presentation and demonstration. We went with a standardized testing system between all of us. Because GNU Radio works best in a Linux environment, we chose Arch Linux as our base operating system. It's a distribution I have a lot of experience in. I wrote a installation script that installed all of the base packages as well as the stuff we need for this project, such as the HackRF drivers, GNU Radio tools, Python 2 and 3, and MATLAB. For the hardware, we chose to go with HackRF 1 because it has a very wide operating range. The antenna that we chose to go with it has a range of 75 megahertz to 1 gigahertz. That's plenty for what we need for this project. The software that we will be using to program the RF front end, which is the HackRF1, is GNU Radio Companion, which allows us to create flow graphs similar to the ones in Simulink for MATLAB, where you create a block, you give it parameters, and then you connect it to other blocks, and it'll program the device that way. Anything that's more specialized, we'll write in Python, and those can be ported over to GNU Radio Companion as custom blocks if that should be necessary.
The second phase of our project is the research of signal detection and classification methods. So, to be honest, that's just a fancy name for us learning as much as we can about both software-defined radios, digital signal processing, and signal characterization. The learning curve was really extensive on all of those, but for example, GNU Radio, we design different software-defined radio block diagrams, and we were able to capture whole lots of different signals. We capture signal garage openers, keyless entry devices. We recorded FM radio signals. So all of these type of signals that we were using, we were able to record them, save them into a binary file, and we ended up opening them and processing them using MATLAB. MATLAB, we were able to look at some frequency characteristics of the signals and things that we will use for the signal identification and classification. But that's just a very small portion of what we're going to end up doing. As a matter of fact, we haven't even started on the algorithm, which will be phase 3, which is actually the bulk of our.
I want to inform you about our capstone project. First, our algorithm is being developed to run in GNU Radio and will be programmed in Python. It will measure 8-bit IQ samples, then characterize them through different parameters and return a signal report. Second, our team of talented electrical engineers is implementing this with the funds provided by General Dynamics in the sum of $1,428 for supplies. The potential challenges are the large file size of data to process and Team 2 living in different geographic.
Finally, we have to take everything that we have done from the first 3 phases and put it into action. The implementation phase is the final phase that we'll need to accomplish next semester. During this phase, we're going to be doing live sweeps of the spectrum to test to see if our system operates as it should. After this, we'll clean up the code to make sure the code is as efficient as possible. Thank you.